Let me introduce myself. So I'm Amine Menacer. I'm a natural language processing PhD from the University of Lorraine. And actually, I'm working as lead of research and development department at IMAX company, IMAX consulting company here in France. So in my today's talk, I will present our approach to handle with person job fitting. So the work is entitled an interpretable person job fitting approach based on classification and ranking. So let's start with the brief introduction. So as you know, in traditional recruitment process, the most important steps are the following. So we have to start with the phase of needs analysis and determination of the required profile. We draft after that and publish our job description. We proceed after with the profile search. And among the submitted resumes, we have to evaluate each resume and select the best one in order to program interviews with the selected resumes. So in this process, we can automate the second and the third steps by using online recruitment platforms like LinkedIn, Indeed, Glassdoor, etc. But the issue with this platform is the huge number of users. Here's some statistics about LinkedIn in the last year, 2020. You can see on this platform, we have more than 2 billion of job applications submitted every month. The number of people that are using LinkedIn to search for job each week is more than 40 million. We have 4 people heard every minute on LinkedIn. So you can imagine the huge number of people that are using these platforms. And this makes the process of evaluation and resume selection time consuming. So just to give you an idea about this time, so at our company IMAX, a recruiter needs more than 19 days, to process the application. So in order to optimize this time, we address in this work the person job fit issue. So in this issue, the objective is to propose a model that will be able to do the matching between job description and resumes. And this issue can be considered as job recommendation, skills measuring, candidates matching, and in our case, we consider the issue as candidates ranking. So in the candidate ranking, the idea is from a job description and the set of resumes, our proposed model will be able to attribute a score for each resume in order to measure how similar the job description and the resume are. So in this case, one can consider can use the ranking models as classification or regression. But the issue with these models is that they require a lot of data in order to train them. And as you know, the resumes are considered as confidential data, and it's difficult to read them. And in order to handle with this issue, we can consider or use deep learning models in order to measure the semantic similarities between the job description and the resume. But the issue with these models is that the deep learning models will apply a complex transformation to the input. And finally, it will be difficult for us to explain why this candidate, for example, is accepted and why it's not accepted. So in order to handle the issues in these two approaches, we propose in this work a hybrid approach that takes benefits from the two approaches in order to handle with the person job fit issue. In our proposed approach, we have several steps. So the first step is the document analysis. In this step, we will extract simply text from job description and resumes. So these documents could be a PDF or Word files or text file. So in order to extract text from PDF or Words, we can use standard libraries. But the issue with these libraries is that they fail to process files with complex structure. You have here a simple example of a resume which is written on 2 columns. So if we use directly the standard libraries to extract text from PDF or Word file, so we will get, for example, text from the first column. After that, we get text from the second column, etc. So we will lose the semantic of the text. So in order to handle with this issue, we propose a rule-based approach. We try to cluster or to create clusters by grouping the zone text according to their X position in the original document files. And with that, we will get the text from the first column, and after that, the text from the second column, etc. After that, we have the text, and we will extract from this text features. These features will be used to calculate the final score. And in our case, we consider 7 features. So the first one is the count feature. It aims to measure how similar the resume and the job description are according to the common words between the 2 documents. So the idea here is to extract or to project each document on multidimensional vectors by using the frequency of words in each document, and after that to calculate simply the cosine similarity between the 2 vectors to obtain the count feature. The second feature is the TF IDF feature. So the idea here is based on the same idea of count feature. We integrate the inverse document term, the IDF term, and we calculate the cosine similarity between the obtained vectors. In the third feature, we try to capture the semantic relation between the document tokens in the job description and the resume. So for that, we trained simply a doc2vec model by using more than 2,300 job resumes collected from online contents. And the trained model will project each document on 50-dimensional vector, and we calculate the cosine similarity between vectors to obtain the semantic feature. We consider also the skills feature. So the idea here is to use an entity recognition model to extract the required skills from the job description and the acquired skills from the resume, and to calculate the ratio between the skills to obtain the skills feature. We consider also the experience year features. So the idea here is to extract all dates from the experience section from the resume, and by using rule-based approach based on regular expression, and to calculate the date of the experience years of the candidate. After that, we consider also the spelling error features. So here we used a list of French words as a lookup table, and for each token or word in the resume, if we find that the word exists in the list, so it will be considered as a correct word, and otherwise it will be considered as a misspelled word. And finally, we integrate a feature in order to know if a resume is well structured or not. For this, a good resume should include the following information. So the contact information, the education section, experience section, and skills section. And it should respect the following constraints. So the non-presence of personal information, for example, the marital information or status, for example, and the resume should, or the number of page should be less than 3 pages, and the candidate should use short sentences. And for that, we define a function. If we find that the constraint is respected, so we add 1 to this function. Otherwise, it will be equal to 0. Now we have 7 features. In the last steps, we will combine all the features in order to have 1 score. And for that, we propose 2 approaches. So in the first approach, we calculate the final score as a weighted sum. So we attribute a weight for each feature, and we calculate the sum to obtain the final score. And the second approach, we use a machine learning based approach. So for that, we use the 7 extracted features, in order to train classification models to classify the candidates into two categories, accepted or rejected, and after that to use the classification probabilities as score. Now, in order to evaluate our approach, we used French data sets. It's an internal corpus that contains more than 2,000 candidates resumes that were applied to 121 jobs. So we have 121 job description and more than 2,000 resumes. And among these, so in this corpus, we have 29% of accepted candidates and 71% of rejected candidates. So in order to evaluate the first approach, the one based on the weight score approach, we used 10% of the corpus to estimate the weight of each features and 90% for evaluation of the approach. And the evaluation was carried out by calculating the precision of the model to rank the accepted candidates among the top N candidates. So we find that the precision of the model to classify the accepted candidates among the top 5 candidates is 70%. And if we consider the top 10 candidates, so we have precision of 88%, which is pretty good. And we find also that by assigning a high weight to features extracted from jointly the resume and the job description gives better results. These features are the count, the TF-IDF, the semantic, and skills feature, the four first features. Now, in order to evaluate the second approach, the one based on machine learning based approach, so in this case, we used 80% of the corpus to train the several classification models. We trained the random forest, K, nearest neighbor, multi-layer perceptron, support vector machine, and logistic regression classification models. And in order to compare these models, we used 10% of the corpus. Here, the results in terms of precision and F1 score. It should be noted that in these results, we have to consider the F1 score because we have an unbalanced data. If you can see here, we have 29% of the accepted candidates and 71 of the rejected ones. So we have to consider F1 score to have a good comparison. And the best model was the random forest with the F1 score of 84%. And you have here the result in terms of the confusion matrices. You can see here that the best model recognized the rejected candidates with a precision of 97% and the accepted one with a precision of 77%, which is considered as good results. And as final test, we measured the importance of each features to train the classification models. So we try to train the difference model by using different features and to compare the performance of the model with and without the features. And we found that the best features are the one extracted from the resume and the job description. You can see here the count, the doc2vec, skills, and TF-IDF feature, which confirms the results obtained with the first approach, the one based on semantic or the weighted sum approach. Now I will conclude with simple demonstrations. So I will show you a simple implementation of our model. You can see here, I don't know if you see my screen or no, because yeah, okay, thanks. So here you can see that we have two options. So in the first option, we can select the job description. It's with French because we worked on French resumes. And we can select a set of resumes. In the second option, we can select the job description, and we can search for candidates from online recruitment platform like APEC. It's French platforms, DoYouBuzz, Indeed, etc. So I will show you the result with the first option. here I will select a job description. You can see it's text file containing the description of the job. It's with in French language. And I can select a set of resumes. Here I will select, for example, 1, 2, 3, 4, 5. So 5 resumes. And I can start the scores calculation. So in this stage, we will extract features, the 7 features from each resume, and we will combine the extracted features in order to get the scores of each candidate. And as a final result, we will get, a list. So we will get a list of sorted candidates. So the sorting is carried out according to our score. You can see here we can get several information about the candidates. We can get the contact information, the experience years of the candidates. So here you have the language used in the resume. Here you have the spelling errors. Here you have the information about the skills. The green skills are the acquired skills, and the red ones are the required skills. Here you have the information about the light feature. You have the different constraints. If the constraint is green, which means it's respected, and if it's yellow or orange, it's not respected. And you have here the different scores. So you have the doc2vec scores, the TF-IDF, and the count scores, and the final score. So that's all. Thank you for your attention. And if you have any questions, don't hesitate to contact me at this email address.